Okay, I know you're midway through the period now, but let's kind of pause and take a check for understanding about this recentering, rescaling stuff, because usually I assign that video that you just watched as an overnight homework and then we talk about it in class the next day. And I want to make sure you understand. So this says Ms. Kramer calculates her students' progress reports grades and sees that the mean grade is an 82 with a standard deviation of 12. She realizes that she has made a mistake and that she can fix this mistake by subtracting 10 points from each person's grade and multiplying the result by 1.1. I want you to calculate what the new mean and standard deviation of my students' grades would be. So please pause the video for 2 minutes and allow students to answer this question. Okay, so you learned in the video that the mean is affected by both recentering and rescaling. So subtracting 10 points, that would be classified as recentering because every grade is just being subtracted by 10. And then multiplying by 112, that would be classified as rescaling. So essentially the new mean, to get that, we're going to take the old mean, which is 82, we're going to subtract 10, and then we're going to multiply that result by 1.1. So 82, if we subtract it by 10, we're going to end up with 72. If we multiply that by 1.1, we end up with 79.2. So the new mean would be 79.2. This keeps us from having to recalculate each individual grade, which we don't even have. We can just apply that transformation directly to the mean. Now the standard deviation is a little bit trickier because standard deviation is a measure of spread. And as you learned in the video, measures of spread are not affected by recentering, but are only affected by rescaling. Because if I subtract 10 points from each student's grade, they don't get any more or less spread out. They just shift. All right, so to find the new standard deviation, I'm going to take the old standard deviation of 12 and multiply it by 1.1, and that's it. Okay, so this is going to become 13.2, and that's it. I don't worry about the minus 10. I want to answer some common questions about that topic. So first of all, a question that I often get asked is, does the range get affected when you recenter? Well, let's think about this. Range measures what? Range is a measure of spread, right? So if I recenter, no, the range will not be affected. The range is the maximum minus the minimum. So for example, if the maximum goes up 50 units and the minimum goes up 50 units, the distance between them stays the same. Rescaling, yes. Okay? Because if I'm multiplying each individual value by a constant, they may get more or less spread out. Okay? And so no, it would not be affected if we recenter. Yes, it would be affected if we rescale. Next question is, will the IQR or Q1 change if all students' grades are improved by a point, for example? Again, we need to ask ourselves, is this a measure of spread? IQR is a measure of spread. And so if all students in grades improve by a point, well, Q1, yes, will improve by a point, but Q3 will also improve by a point. So when I subtract them, I still get the same distance between them. So IQR, no, will not be affected. Q1 itself, yes, will be affected. Division or subtraction, I didn't mention these explicitly in the video, but you probably figured it out. Division follows the same rules as multiplication. Subtraction follows the same rules as addition because multiplication and division are really the same thing. Addition and subtraction are really the same. Similar question, why would the quartiles change but not the IQR when you're recentering? So I want you to think about this. Let's say I have a really, really simple data set. 1, 2, 3, 4, 5. 6. And so the median is between the 3 and the 4, which means Q1 is 2 and Q3 is 5. So Q1 is equal to 2, Q3 is equal to 5. The IQR is the difference between them. 5 minus 2 is 3. Let's say I recenter. Let's say I add 100 to each of these. This becomes 101, 102, 103, 104, 105, and 106. Median is still here between those two values. Q1 is now the median of everything to the left of the median, which is 102. Oh, hey, Q1 got affected. Q3 is the median of everything to the right, which is 105. Oh, hey, Q3 got affected. But the IQR is the distance between them. And the distance between them, even though I added 100 to each of them, is still 3. The final question that I often get asked, sorry if you can't quite read this, if we're doing things like this that involve units, centimeters, meters, feet, are we always going to be given the unit conversions? For example, there are 2.54 centimeters in an inch. Or are you going to have to memorize those? You do not need to memorize those. If you need a unit conversion, you will be given that unit conversion, okay? I'm trying to test to see if you understand recentering and rescaling, not if you have memorized how many centimeters are in an inch. Okay, so we've learned 2 sets of ways to summarize center and spread. It should be pretty clear that median and IQR sort of go together, and mean and standard deviation sort of go together. Median has to be used in order to find the quartiles, which you use to find the IQR. Standard deviation is the average distance to the mean. These 2 pairs of center and spread are linked. But the question is, when do you use which summary? Up until this point, I've said use whichever is easiest, use whichever one you can pull off of the graph, use whichever one you like better. And on the AP exam, that stays true. However, there are some guidelines for when it's better to report out something like median and IQR and when it's better to report out something like mean and standard deviation. It depends on if you need resistance, and I'll explain what I mean by resistance. If you have a distribution with outliers or a strong skew, it is advisable to use median and IQR. That's because median and IQR are resistant to outliers and skewness. Okay? If I say something like the median salary is $45,000, most people hear words like mean and median and they think typical. Okay? And so reporting out the median salary is $45,000, if I have a strongly skewed distribution, the median is still going to be a middle value. If I have a distribution that's reasonably symmetric and free of outliers, then we can use mean and standard deviation. You're going to see in Chapter 2 that mean and standard deviation are much more powerful in terms of calculation, and we'd like to be able to use them. However, if I report out mean and standard deviation in a highly skewed distribution, we've seen that the mean gets pulled towards that skewness, like it did in the hair lab. Okay, so if I say that the mean salary at a company is $70,000, but the median was $45,000, well, that median value is probably going to be a lot more typical than the mean. Okay, so to illustrate this again, what happens to the mean when we have skewed data? What did adding Tran Van Hey to your hair lab group do to the mean? Well, it increased the mean a lot, okay? And so the mean no longer is a representative typical value in a skewed distribution. That's why we would use the median. So let's look at some examples. If the data is skewed right, the mean gets pulled to the right, whereas the median stays pretty close to the bump in the data. Skewed left means the mean gets pulled to the left. So the mean gets pulled in the direction of the tail or in the direction of any strong outliers. Let's look at some visual examples. Here I have an approximately normal distribution. In a distribution that's symmetric like this one, the mean and median should be equal and should be right there in the middle, right at the highest peak. In this distribution, which is skewed, which direction? Skewed right? The mean is really going to get pulled towards this tail somewhat severely, whereas the median is going to stay fairly close to that peak. So in a skewed right distribution, the mean is going to be greater than the median. That's actually a test for skewness. If you don't have the original data, but you know the mean and the median, and you know that the mean is larger than the median, that tells me that that distribution should be skewed right. Whereas if the mean and the median are approximately equal, then I have an approximately normal distribution. In one like this one, which is skewed left, because the tail is on the left, the mean again gets pulled towards that tail, and the median stays fairly typical. And so I end up with a situation in which the mean is less than the median. So again, if I'm given just some summary stats rather than actual data, and I notice that the mean is a good deal less than the median, that indicates to me that I have a skewed left distribution. Since we have a little time and we are nearing the end of the chapter, I thought we could review ogives a bit. That seems to be something that students often want to see an extra example of. So I have a few questions for you off of this cumulative relative frequency graph. My first is, what SAT reading score corresponds to the 60th percentile? My second question is, if I converted this to a histogram, what would its shape be? We'll get to that one next. So pause the video for 2 minutes and allow students to answer these two questions. Okay, if you recall, the percentiles can be found on the y-axis of an ogive. So I'm going to find the 60th percentile on the y-axis. I'm going to trace it over. I'm going to trace it down, and I see that it's a 550. In other words, 60% of students got a 550 or lower. I'm going to write that out. 60% scored a 550 or lower. All right, I said if I converted this to a histogram, what would its shape be? Do not say skewed left. I know you want to say skewed left because you see this curve and you see something that looks like a tail, but that is totally thinking about this in the wrong way. In order to think about this in terms of a histogram, we need to see the relative steepness or the relative slope of each line segment. So what I notice is that these first few segments are not very steep. The slope is really pretty shallow, which means I'm not accumulating very many students in these bins. Not accumulating many students means that the heights of those bars are going to be pretty small. Then around 400, 450, these segments start to be a bit steeper. That means lots of students are getting on the bus. I have higher frequencies, okay? And then in a relatively symmetric manner, I see it start to straighten out again. I have a smaller slope, a slope closer to 0, which means I'm accumulating fewer students and those bars get small again, okay? Do you see how I went? Small slope, bigger slope, small slope in a symmetric manner. So small bars, tall bars, small bars. And what shape is that? Please say approximately normal. Couple more questions. Here I have two ogives superimposed on top of each other, one for 5th period and one for 6th period. Okay, I just made this data up. My first question is, what is the median score for each class? And my second question says, what is the flat or horizontal section on the 5th period ogive, that's right here, tell us? Pause the video for 2 minutes to answer these two questions. Okay, for the median score, you needed to remember that the median is synonymous with the 50th percentile. So I'm going to 50 on the y-axis, and I'm tracing over. And it actually looks conveniently, like they intersect there. So I think they have the same median. I trace down and it's roughly a 75. So ordinarily I would have two answers to this question, one for fifth period and one for sixth period. It just so happens that they have about the same median. So the median for each class is about a 75. Now, what did the horizontal section on fifth period indicate? Well, it indicated that nobody scored between a 55 and a 65. Nobody got on the bus between those two stops. The last thing I want to teach you today is about comparing two distributions. This is a very, very common question on the AP exam. They'll ask you to compare, and then they'll give you two histograms or two box plots or two dot plots. And they're not going to say it, but what they want you to compare is center, shape, and spread. Okay, center, shape, and spread are really the key ideas of this chapter. And so the nice thing about this is that you truly have to just compare them. You don't actually have to give a measure for the center or for the spread. You just need to say which one is bigger, okay, or which one is smaller. For shape, don't really compare. Okay, so for center, you're going to compare. For spread, you're going to compare. But for shape, you're just going to give the two shapes, okay? Don't say one is skewed righter than the other. That just sounds silly. All right, so hopefully you can see the x-axis on these. On this one, it starts at 70. It goes up to like 115, 120. A lot of the bars are in the 80 to 90 range. This second histogram starts at 70, goes all the way up to 130, and most of its bars are in the 100 to 110 range. Okay, and so I'm just not going to calculate the center. I'm going to say which one is going to have a bigger center. So let's just say that the median of histogram A is less than the median of B. Okay, let's skip to spread. The range for histogram A is going to be about 115 minus 70, whereas the range for histogram B is going to be about 135 minus 70, which again means that histogram B is bigger. So the range of A is less than B. Shapes, I'm just going to give the shapes. A is skewed right, and B is approximately normal. Now what I'm missing here, and this is really, really bad, is I have no context. Now the reason I didn't give context as I went through this summary is because I don't know what the context of this problem is. Let's say it's about temperatures or something like that. So the median temperature of city A is less than the median temperature of city B. The range of temperatures in city A is less than the range of temperatures in city B. The distribution of temperatures in city A is skewed right, while the distribution of temperatures in city B is approximately normal. Now I know what this problem is about, and I've talked about context over and over and over again. So again, if you're asked to compare distributions, that means you need to compare their centers in a comparison way. I gave no numbers. I just said which was bigger. You need to compare their spreads, and then you need to give both shapes in context. One interesting graph that can be used to compare two distributions is called a back-to-back stem plot. Now, a back-to-back stem plot can be used to compare like distributions for two different groups. So let's say I have heights of males, let's say in inches, and then I have heights of females in inches, okay? And let's say the male heights are like 65, 66, 68, 70, 71, 71, 72. And then the heights of females are 59, 60, 60, 65, and 70. Okay, I left them in order. What a back-to-back stem plot does, which is pretty cool, is that it reuses the same stem for both distributions, and one has leaves going off to the right and the other has leaves going off to the left. So I know by combining these two that my stems need to go from 5 up to 7. So 5, 6, 7. And let's say I put females on the right and males on the left. I would label this. For females, I have 59, and then I have 60, 60, 65, and 70. For males, I don't have anything in the 50s, so I'm going to leave that blank. I have 65, and usually you jut it off to the left. So 66, 68, 70, 71, 71, 72. That's a back-to-back stem plot. Draw a little circle around it. And it allows us to make comparisons between males and females on the same graph. Okay, that is the end of this lesson. It's actually the end of chapter 1. So you have made it through the first chapter of AP Statistics. Here is homework number 5. If there's class time left, you can start working on it. Tomorrow's Friday, we're going to begin working on some AP practice problems. And then the following week, we don't have any school on Monday. Tuesday, let me write this out for you. Tuesday is going to be a day for you to review. You'll get your quizzes back. You'll get to ask each other questions on those. If there's time, you can work on some homework. Wednesday, I'm going to give you an actual review video. It's not long. And then Thursday of next week, that's September 10th, is your chapter 1 test. Okay? Friday of next week, we will begin chapter 2.